In number 73, again, we're given the zeros to an equation, and we're asked to write it in factored form. Let's start. Y equals, the factor for the 0, -4 is x minus -4, or x plus 4, x minus 3, and x minus 7. Let's set up a number line that shows these zeros, and we'll use it to solve the inequality in part B. Again, we have zeros at -4, +3, and +7. Our inequality is greater than or equal to 0, so we can actually include these endpoints. Now what we need to do is we need to test values in each section on this graph to see if they satisfy our inequality. Picking values in each section. Less than -4, I'm going to use x equals -5. Between -4 and 3, I'm going to use x equals 0. Between 3 and 7, I'm going to use x equals 5. And from 7 up, I'm going to use x equals 10. Notice I'm just picking values that are easy to work with. When I plug these values in to the equation, I actually don't even need the numeric values. I just need to know if they're greater than or equal to 0. When I plug -5 into the equation, I get that the first factor is negative, the second factor is negative, and the third factor is negative. Therefore, y is negative, and it does not satisfy the inequality. When I plug in 0, I get that y is positive, negative, and negative. When you multiply out two negatives, you get a positive. Therefore, my result for x equals 0 is greater than or equal to 0, and I can shade this portion of the graph. Let's go on and check x equals 5. If x equals 5, x plus 4 is positive, x minus 3 is positive, and x minus 7 is negative. Y then is negative, and this does not satisfy our inequality. Based on our results so far, x equals 10 should definitely work. Y equals 10 plus 4 is positive, 10 minus 3 is positive, and 10 minus 7 is also positive. Therefore, y is positive, and this section of our graph, again, satisfies the inequality. Now let's write the results that we've graphed for our solution. Our solution will include all of the values from -4 to +3, including both endpoints. We'll combine that with the set of values beginning at 7 and going all the way to the right, which is infinity. And this is our solution.